Greetings, fellow travelers of the information superhighway. Ernie here, ready to warp you into the fascinating world of Agentic Vehicular Routing. Now, I know what you're thinking. Routing, really? But hold on to your hats, because this isn't your grandma's GPS we're talking about. This is next level, context-aware, almost sentient navigation. So, imagine you're standing in a bustling cosmic metropolis. Cars are zipping around, each with its own unique agenda. Now, traditional navigation systems? They're like single-minded robots, laser-focused on the shortest or fastest route. But what if you need to grab groceries and avoid that perpetually gridlocked street near the old clock tower? That's where the paper, beyond shortest path, Agentic Vehicular Routing with Semantic context, comes in. These brilliant minds, Braun, Jarczewski, Talasso, Villas, and de Souza, over at the Institute of Computing at UNI, have conjured up PAVe, or Personalized Agentic Vehicular Routing. Catchy, right? It's like having a tiny, super smart co-pilot who actually understands what you want. The core idea: traditional systems optimize for singular metrics, time, distance. Add multiple metrics, things get complex. They don't interpret the driver's semantic context. PAVe, it uses a large language model, an LLM, to understand your needs, preferences, and even your avoidances. Now, how does this digital wizardry work? Let's construct a mental map, a memory palace if you will, to guide our exploration of PAVe. Imagine a futuristic cityscape floating among the stars. Each building represents a key step in PAVe's process. First, we enter the user input plaza. This is where you tell PAVe what you want in plain English. Take me to the museum, but I need to stop for gas. Simple, right? Next, we teleport to the LLM Task Classification Dome. Here, the LLM takes your request and figures out what's important. Is that gas stop an emergency? Is the museum visit just a leisurely desire? It's like having Rick Sanchez decode your brainwaves, but, without the burps. Then, we zoom over to the routing engine factory. This is where the system generates a few possible routes using a multi-objective Dijkstra algorithm. That's just a fancy way of saying it finds the best routes based on both time and CO2 emissions. Eco-friendly and efficient? I like it. But wait, there's more. Now we arrive at the geospatial context enrichment spire. Here, PAVe taps into a pre-processed geospatial cache, basically, a giant database of points of interest, or POIs, supermarkets, hospitals, parks, you name it. It's like PAVe is scanning the city for all the things that might be relevant to your trip. Finally, we ascend to the Agent Evaluation Observatory. This is where the LLM agent looks at all the routes, all the POIs, and your stated preferences, and decides which route is best. It's even got a feedback loop launchpad, so if it needs to add a waypoint, like that gas station, it can recalculate the route on the fly. Fine, yeah, I guess. Look, the point is, this paper is a big deal. Now, picture this. You're late for a very important meeting, and you need coffee. PAVe understands the urgency, reroutes you to the nearest caffeine dispensary, and gets you to that meeting just in the nick of time. Crisis averted. Or, imagine you're trying to avoid a certain part of town because of, say, a zombie convention. PAVe knows this, takes a different route, and saves you from becoming a zombie snack. And get this, in their experiments, PAVe achieved over 88% accuracy in initial route selections with a local model. That's seriously impressive. The authors used real-world urban scenarios based on Luxembourg. Yes, the place, not the holding company. They tested PAVe in situations like simple task, urgency, avoidance, and efficiency. It's like they were putting PAVe through its paces in a real-life driving simulator. Now, you might be thinking, okay, Ernie, this sounds cool, but what's the catch? Well, the authors themselves admit there are limitations. The system can sometimes struggle with generating the correct action schema, and the feedback loop can only handle one waypoint addition at a time. But hey, that's science. It's all about pushing the boundaries and finding new ways to improve. They even note an inconsistency in the agent's generation of the correct action schema. They are thinking of using distributed learning to preserve user privacy. So, there you have it. PAVe, Personalized Agentic Vehicular Routing. It's a glimpse into a future where our navigation systems are more than just route planners. They're intelligent assistants that truly understand our needs. It's like having a digital chauffeur who knows you better than you know yourself. Keep exploring, keep questioning, and never stop seeking the next great discovery. This is Ernie, signing off.